Hello everyone, welcome to this episode. This is SID 46, one of the E8 projections, our third significant E8 projection, and the one that nearly slipped through. This SID failed our standard RMS tournament. Its average distance to the nearest edge wasn't exceptional enough to pass the search PS corrections. But when we looked beyond the average at how sites are distributed across distance, we found something the RMS test completely missed. 48% of all circuit sites, 77 out of 160, fall within 0.02 degrees of an E8 edge. So that's 2.2 kilometers. To give you a sense of scale, SID 3's statistically significant threshold was 11 kilometers. SID 48's was 5.6 kilometers. And SID 46 operates at 2.2. The probability of achieving this by chance, even after giving the null model full freedom to optimize, is 1 in 100, with an effect size of 2.71 standard deviations. So let's have a look. If we zoom in to this massive web of edges, the E8 lattice SID 46. Zooming on Halifax, Nova Scotia, which is one of the circuit sites and is marked in green here. So this site is among the 70 sites that falls within 2.2 kilometers. So this is quite precise projection. So you can see this is 0.7 kilometers nearest grid distance. Now zoom in a bit further for you to have proper look. Halifax, Nova Scotia. You can see the edge is very close to the circuit sites. Now I'm coming to the second layer, the supported edges. So now I'm filtering to just 91 edges out of 6,720. that pass within 2.2 kilometers of a circuit site. That's barely 1.4% of the lattice. Yet these edges account for 77 sites from every inhabited continent. So look at the stands out. Fox Islands in the Aleutian chain sits near 3 edges. So if we look at Fox Islands, if we go there, all right, Fox Islands, just in Canada, we can see it sits near 3 edges, just here. So it's a major node at this extreme precision. Mount Fuji, if we go to Mount Fuji in Japan, it's near 2 edges. So we have Mount Fuji, the Mount of Olives, Hamland Pool in Western Australia, Stortorget in Stockholm, and Shout El Jerid in Tunisia, each near 2 edges. I'm going to Tunisia and show you the precisions of those edges. But you can see that the Mount Fuji shows 2 edges passing through the center of the mountain. And I'm going to Tunisia now. Shout El Jerid. in Tunisia. So we're here. Here we are. So let's short algebrate. And it has also two closed edges near. So the Great Pyramid of Gizeh, Mount Kailash, Uluru, Angkor Wat, the Forbidden City, each within 2.2 kilometers of an innate edge. So if we go to Angkor Wat, I can show you the precision of this projection of the E8 lattice. On this one, we can see only one edge near of this second side, but it's very close. So if I click on it, 0.3 kilometers away from the edge. So as this story runs, there is no shared edges. No single edge passes within 2.2 kilometers of two sites at once. So I can show you the third layer because there is no edges fulfilling this. So you can see this is the layers which should show edges passing simultaneously through two sites or more, but there is none in this particular projection. So SID 46 is not about connections between sites, and it's actually the point. It's about placement precision. Individual circuit sites sitting almost exactly on the mathematical lattice itself. Compare the three SIDs we've confirmed. SID 3 gives you a rich network with 367 supported edges, 19 shared connections linking site pairs, Uluru to Katajuta, Gizeh to the Mount of Olives. So the strength is breadth. 97% of site within 11 kilometers. SID 48 gives you tighter geometry, 198 edges with 7 shared connections, Glastonbury to Shepherd's Bury, the Easter Island cluster. Its strength is precision, 83% within 5.6 kilometers. SID 46 gives you something different entirely, 91 edges, but 0 shared, but 77 individual sites landing directly on the lattice within 2.2 kilometers. So we have 3 projections, 3 completely different signatures, each significant where the others aren't. So now I want to show you something we didn't expect, something that only became visible once we had 3 confirmed SIDs to compare, 3 confirmed E8 projections to compare. So look at the orientations. If you have previously read my articles on SID 3, latitude was 65 degree north and the longitude 125 degree east, and the bearing was 250 degrees. For SID 48, latitude is 5 degrees south and longitude is 135 degree east, and the bearing is 250 again. And for SID 46, latitude is 55 degree north, the longitude is 175 degree west, and the bearing is 250. So we have 3 different projection SIDs, each producing a completely different set of 240 vertices and 6,720 edges. So we have 3 different latitudes, 3 different longitudes, but the bearing, the rotation of the lattice around the Earth polar axis, is 250 degrees in every case. So our search tests 36 possible bearings in 10 degree steps and the probability of 3 independent optimizations landing on the same value by chance is roughly 1 in 1,300. That's not proof. 3 data points are suggestive, but not conclusive. But consider what will it mean if it holds. The bearing parameter controls how the EA lattice is twisted relative to the Earth rotational axis. So if multiple projections independently converge on 250 degrees, that will imply a preferred geometric orientation, a specific angle at which a dimensional structure aligns with our planet's spin. We are running 100 more seeds, more projections to analyze right now to test this. And if bearing 250 degrees keeps appearing, if 5, 6, 7 more seeds all prefer the same twist, we'll have something much stronger than a coincidence. So we'll have a constraint on geometry, but we will let the data decide. So let's look at what we get for the next seed. I'll give you more updates about this, and it's exciting. The E8 lattice uncovers more of its structure and data. The data will give us more information. Thank you very much, and I'll see you for the next episode.